Let's look now at some functions that we cannot evaluate the limit just by plugging in. This function, notice, or this question asks us to evaluate the limit of x cubed minus 1 over x minus 1 as x approaches 1. You can easily see that if I tried to plug in 1 into the denominator, I would get 0, and that's going to make me divide by 0. I can't do that. Now, notice also, though, that if I plug 1 into the numerator, I get 0 also. And we get this very specific indeterminate form, 0 divided by 0. And whenever we see that, we suspect that there is something that we can do to make this problem go away so that we can actually evaluate the limit. It doesn't always happen, but very often we're able to manipulate this so that we can actually find the limit. And our first line of defense here, our first tactic that we would try is to factor the numerator and the denominator. Now this one, the denominator is already factored. We can't really factor anything out of x minus 1. But what we can do is factor that numerator, and we should know this is called our difference of cubes. If you need to look that up, we have talked about this before, but if you don't remember, it's called the difference of cubes. Just search for difference of cubes, and you'll find that this should factor to x minus 1 times x squared plus x plus 1. Okay. And so we factor the numerator and the denominator, and we see very conveniently that one factor of the numerator, x minus 1, can divide with one factor of the denominator, x minus 1, and they divide out to 1, and we usually call that canceling, but remember they are actually dividing out to 1. And so we end up with just this quadratic function here, x squared plus x plus 1. Now, one thing you do have to be careful about here is if you went into a calculator and graphing calculator or some graphing utility, and you tried to graph this function that we started with, if you tried to graph x cubed minus 1 over x minus 1, it's going to look like this parabola. It's going to look like x squared plus x plus 1, because most of the time, that x minus 1 and the x minus 1 in the numerator and the denominator, they don't really make a difference. Where they do make a difference is when x equals 1. And when x equals 1, we get a little hole in the graph, and remember we call that a removable discontinuity. And once we know what the limit of this function is as x approaches 1, then we will know where exactly that hole is. So now that we have eliminated the offending terms, the things that made us divide by 0, we are now safe to plug 1 into the leftover function. So x squared plus x plus 1, so I have 1 squared plus 1, which is just going to give me 3. And so that limit of that original function as x approaches 1 is 3, which means this little hole is at 1, 3. And so what happens is this original function that we started with, x cubed minus 1 over x minus 1, it just gets really close to that 1, 3, but it never quite gets there, because if we try to plug 1 in, it just doesn't work. Okay, so let's look at one more that works exactly the same way. We look at this function and we say, well, we're trying to do the limit as x approaches negative 3. Clearly, if I plug that into the denominator, I'm going to get 0. And so that's a problem. But we notice that negative 3 squared is 9, and 9 plus negative 3 is 6, and 6 minus 6 is 0. So once again, we're getting this 0 divided by 0. And we say, wait, something might go away if we just factor. So we're hoping that one of the factors of the numerator is x plus 3, and we think about it and we say, well, yes, if we factor, we can factor it to x plus 3 and x minus 2, and that way we get x plus 3 in both the numerator and the denominator. We divide those out and they become 1. Again, if you tried to graph this function, you would see that it looks like the graph of the line y equals x minus 2. So positive 1 slope and a negative 2 for the intercept. But it's going to have a hole wherever x is equal to negative 3. And so we just continue trying to evaluate that limit, and we say the limit as x approaches negative 3 of the function x minus 2 would just be negative 3 minus 2, which gives us negative 5, and that matches nicely with what we predicted from our graph here. This graph has a little hole at negative 3 comma negative 5, a removable discontinuity, and the limit does exist. Dividing out factors, that's always a good approach to think of when we come across one of these 0 divided by 0 problems, but it's not, unfortunately, always going to work. So we do have another technique that we can try, and that is called rationalization. I'm going to back up for a second. I'm going to remind you of when we looked at things like 1 divided by the square root of 2. And remember, when we did that, we didn't like the square root in the denominator, so we multiplied by 1. But we made it look like this. We said square root of 2 over square root of 2. That way, 1 times the square root of 2 just gives me square root of 2. And then square root of 2 times square root of 2 gives me 2. And this is how we normally write that out. And we called that rationalizing the denominator. Now, that's just a reminder of how we did some rationalizing when we were dealing with simpler stuff. Same thing will work with a function, with some of these functions that look kind of like this. First of all, notice we have a square root here. That's kind of a sign that we might have to do some rationalizing. We'll see. So notice if I try to plug in 0, obviously I will be dividing by 0. But again, in the numerator, if I plug in 0, 0 plus 1 is 1, square root of 1 is 1, and 1 minus 1 is 0. So again, I'm dealing with this 0 divided by 0 indeterminate form. And I think, well, maybe I can do something to this. But obviously, what would I factor here? There's not anything that clearly factors out. So what we do is, just like before, we're going to multiply by 1. But this is going to be a little messier. So what we're going to do is we're going to take the conjugate of the piece with the square root in it. So remember that conjugate means we just take that middle sign and we change it. So we're going to say square root of x plus 1 divided by square root of x plus 1 plus 1. Okay? And again, we're just multiplying by 1. All of this mess that we just added here, that just comes out to 1. It's just we're multiplying it by 1, so we're not changing the value, we're just changing how it looks. And now, this looks pretty complicated, but it's really not as bad as it looks. All we have to do is do a little FOIL on top. So I say square root of x plus 1 times square root of x plus 1, and the square roots cancel, and I just get x plus 1. And then I would say square root of x plus 1 times positive 1 is going to give me plus square root of x plus 1. And then square root of x plus 1 times negative 1 for the inner two terms, I get minus square root of x plus 1. And then finally the last two terms, negative 1 times positive 1 gives me minus 1. And in the denominator, I'm not actually going to multiply anything out. I'm just going to say this is x times the square root of x plus 1 and then plus 1. Okay. And what I notice here is, first of all, that in the numerator I have plus 1, and then I have minus 1, which is just 0. And I have plus square root of x plus 1, and I have minus square root of x plus 1, which is also 0. And you'll notice I can rewrite this. Now all I have left in the numerator is x, and all I have left in the denominator is x times square root of x plus 1 plus 1. And notice that since I have the x in both places, I can say x divided by x is just 1. And so I can say, I should have been copying my limit as I went along. I want to know what is the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And this is now safe to plug 0 in, and I just do that, and I say 0 plus 1 is 1. Square root of 1 is 1. 1 plus 1 is 2. So in the numerator I get, in the denominator I get 2, and numerator is obviously just 1. And so I find that that limit is 1/2. So I have two basic concepts that I think of when I see this 0 divided by 0. One thing I can try is dividing. Try factoring things, see if anything will divide out. The other thing I'm going to try might be rationalization. And it's a little more complicated, but sometimes it works.